Here's problem 1614. Write the equation of a wave traveling along the x-axis with an amplitude of 0.02 meters, a frequency of 440 hertz, and a speed of 330 meters per second. In general, for a wave, we're going to have y is equal to some amplitude, cosine kx minus omega t, could be sine depending on the phase. So, in this case, we know the amplitude. That is given as 0.02 meters. We want to determine the angular frequency. Now, the angular frequency would be 2 pi times the frequency. So that's going to be 2 pi times 440 hertz, or 880 pi radians per second. So that will be our angular frequency, 880 pi. And then now we want to find the wave number. Now the wave number should be equal to 2 pi over the wavelength. And we know that the velocity is the wavelength times the frequency. So the wavelength is going to equal the velocity divided by the frequency. In this case, 330 divided by 440. Hence, we'll have that the wave number, which is 2 pi over the wavelength, is going to be equal to 2 pi over this 330 over 440, or in other words, it's going to be 2 pi times 440 divided by 330, or 880 pi divided by 330. So this wave number term is 880 pi divided by 330. Now putting all these terms together into our wave function, we have y is equal to 0.02 for the amplitude, cosine or sine depending on our phase angle phi, of our wave number, 880 pi over 330 times x, minus our angular frequency, 880 pi times t, plus a phase angle. If we factor out the 880 pi, then we have that this is equal to 0.02 cosine or sine 880 pi times x divided by 330 minus t plus a phase angle. Well, looking at our possibilities, we have either a or c as a sine function. In other words, we're going to choose our phase angle in order to make this a sine function instead of a cosine function, adding pi over 2. Since it's traveling in the positive x direction, we should have a minus for our omega t instead of a plus. That gives us the option of answer A instead of answer C, because we need that minus sign right there to travel in the positive x direction. So our final wave function to correlate with the possible answers is 0.02 sine 880 pi x over 330 minus t. And we choose the phase angle to give us the sine function, and there's our wave function.